everyone, welcome to Math Moment with Mr. Dustin. I am Mr. Dustin. So today we're going to be discussing variables. Now this is something that comes up very frequently in algebra, and this is the beginning of our algebra section for the summer. And so let's get right into it. A variable. Now what on earth is a variable? Now some of you may have heard of it before and others of you may not have, so I'm just going to go over all the ways it can be used and that kind of thing. So a variable is a changing quantity. Now, we can kind of see in this equation here, we have many variables. The variables tend to be like these letters here, y, x, and in some cases, even this a and b when we don't know what they are, and we'll get to that kind of application in a minute. But what I really want to highlight is the x and the y. Now, in this function here, this equation, we have y equals negative 5x plus 4. Now, we don't know what x or y are. They could be anything. We could put anything we want into those. Let's say I want to put 1 in as x, just because I like 1. So when that happens, we need to adjust y in order to make this equation true. So we do negative 5 times 1 is negative 5, plus 4 is negative 1. And that is what y is. So in order to make this equation a true statement, we say negative y is equal to negative 5 times 1 plus 4. That is a true statement. Now, we could change that statement a little bit because y and x are changing quantities. So let's say we want 2 for x. Well, that's going to mean y has to be equal to negative 5 times 2 plus 4. Well, if we solve this again, negative 5 times 2, well, that's negative 10, plus 4 is negative 6. So this time, negative 6 is equal to y. And so our full statement is negative 6 equals negative 5 times 1, or not 1, sorry, 2. I was reading the statement way above, plus 4. So these are both accurate, these are both true, and that shows us that variables change. They can change. Now, other applications for these variables or other definitions include variables being known values. When we solve an equation like this, we say, we have 2x plus 4 equals 14. Now, x here is unknown, but it becomes known when we solve for it here. And its counterpart, variable being unknown, is seen in this equation here. Now, we can see we have x here, and we have no idea what it is. And this formula down here will actually tell us that. Fun fact, a lot of variables in there, and these variables are not necessarily numbers. That you'll recognize them as letters, and that's kind of the main thing that sets them apart visually. But they do replace numbers in this case, and we would plug in different numbers from this equation here for some of these. We also have variables that are independent and dependent. Now, this is mainly applicable to collecting data. And so I put a graph here that shows us Apple product unit sales in millions. So basically these lines kind of follow the sales in the data there. But the important thing to note are these different axes. So there's the x-axis and then the y-axis. Now, what is the difference between them? Well, this shows us, looks like a year, and I think these are like the quarters of a year. So you have all of 2012 here and all of 2013. So this would be considered the independent variable. And I'll show you why in just a moment. Speaking of y, we have the y-axis. And that is going to be the dependent variable. This is That's those sales. Now, independent variables can operate on their own, basically. They don't need something else to tell them what they are. So basically, like a year is a year, right? You don't have to figure out what a year is based on some other factor. By contrast, the dependent variable is dependent on the year in this case. So at, let's say 2012 at Q1, well, the iPhones, which are the blue, were up at about here at this point. So that's somewhere between 30 and 40 million sales. But let's look at 2015 in Q2. Well, they were up much higher. At that time, they were somewhere between 70 and 80 million in sales. So that tells us that the sales are dependent on the year, whereas the year is not necessarily dependent on the sale. So when making the distinction between them, that's kind of a good way to go about that. Does one depend on the other? And if so, how? Kind of reason with that in your mind. So these are kind of like the 4 basic ways you'll see a variable in math. And we'll go on to some applications of them and see them applied into equations after the break. So for the break today, I decided to show you a behind-the-scenes view of our pop-ups in the park. So this week we're at Lawrence Street Park for the zoo event. We can see Mrs. Russell walking down to the amphitheater. We're waiting on some supplies, so I'm just hanging out in the play structure. Haven't been here in a long time, so that's pretty fun. We have our helper Jenna down there. Say hi. So yeah, I will show you more when we get our tables. So we got our tables. Now the next task is gonna be wiping down all these chairs because they got wet from overnight. Looks like Jenna started on it. And then we have all our people down there, and then Miss Leanne is over there with the book bike. So that'll be fun. Now on to drying some of these chairs. So now that we've finished drying off the seats, I have my counter here. It's nice and orange. This is new today, so that's kind of fun. And we're just waiting for people to arrive. And I think I'll show you the book bike when it's all set up. So that'll be kind of fun. And we're just waiting for the people from the zoo. So yay. There it is, in all of its beauty, the book bike. And there's the rest of it with Miss Leanne driving it. So we have all kinds of books in here. These kids books, your good old JF books. It looks like we have some graphic novels. That's really cool. Nonfiction, and then let's see, more kids books. Not even a display. This thing is fully equipped. Some tween books, young adult books. There's something here for people of all ages, except maybe adults, but this is a kids program, so this makes sense. And there are even library cards. Wow, that is pretty nice. So yeah, if you come to our events, feel free to stop by the book bike and see Miss Leanne, who's driving them, I think, pretty much all the time. Yeah, so it'll be a lot of fun. So here's a problem-solving opportunity. We found a water bottle up there. I got one down, so that was nice. But this one's kind of wedged in there, so somehow I'm probably going to use math to get it out, but I have no idea how yet, and it might not even come out. So we'll see how that goes. Okay. So the bottle's up there. I'm going to try to get it down with a longer stick. It probably won't work, but we'll see. Is it working?
You're kind of close. There's another stick up there.
Oh yeah.
Like a huge log.
Did it move?
No.
Yeah, I don't think this is gonna reach.
I think you need to either be a little taller or have a little longer. But you're really close. But yeah, someone was definitely water flipping. Water flipping?
Yeah. Yeah, I don't think I can reach that.
I'm still recording.
Are you still recording? All right, oh cool. This has been math. So we finished our event at the park. It was a good time overall, I think. and it rained out. You can see on the windshield in front of us here. So now we're just heading back to the library. We've got a crate here with our stuff in it, and Miss Jess has all the rest of it. So yay, a lot of fun. We'll be back there next week for more events, so feel free to stop by. Hi everyone, welcome back. I hope you enjoyed the break. So let's move on to seeing what some of these variables can be used for within math. So I'm first going to highlight this equation up here. It's a somewhat simple equation with t being the variable there. Now t is basically going to represent an unknown quantity, and we can solve for that by doing some algebra. And now in one of my previous videos from last summer, I did go over how to solve equations using algebra. So I encourage you to check that one out to kind of see how this process happens. But as far as variables go, t is a variable and it is unknown, but we can make it become known. Now let's look at this blue box here. The unknown part of it is the tree, or rather are the trees. So the trees represent an unknown quantity that we're going to find, essentially. That's kind of the idea behind the puzzle. You would find the quantities of these trees and then fill in this question mark here, since you know what the trees are. Other unknown quantities, as I showcased the quadratic formula in an earlier slide. This is from calculus. This is what we call an integral. And you can see there are no numbers. So that might intimidate you. Calculus is intimidating at times. So yeah, very advanced, and you can do it though if you decide to go and go on to calculus. But variables are very common in calculus. Now, what we have up here is kind of a table full of data. Now this is used in statistics, and our variables are known quantities like standard error or R change or R square change or F change. Now, it doesn't really matter what these mean. That's for a professor, like a college professor or a high school teacher to handle. But the point is that these two are variables, and they will have these known quantities, like these numbers that are shown here. Same with the correlation and these significant values. And then another perhaps more common equation that you've seen is the Pythagorean theorem. And these represent unknown quantities or perhaps known quantities on triangles like this. So let's look at some examples outside of math. And these are going to be in fields that are related to math, because like when you use variables, that's kind of getting advanced. And so it's hard to stray away from math entirely. But still, we have some equations up at the top here. These are some famous equations from physics. Yes, physics, which I jokingly refer to as applied math. These basically tell you velocity, displacement, and acceleration somewhat. Like, they're a bit complicated, but these first two are like velocity and displacement, and then this one can be used to find acceleration, which is that A. But the important thing is that they kind of relate to each other, but we're highlighting the variables today. So all of these mean different things. Yeah, so we have V, V naught, A, T, X, X naught, T squared, even this delta here, which actually means change in. So a very complicated equation, but kind of fun. Now, we also have a chemical reaction formula. This is from chemistry. And you'll notice that, yes, we have letters in here, but really they represent elements. And so they represent something that is known. And they're not going to be variables in the traditional sense, but you will see them in chemistry. Now, here we have something from statistics and discrete math. And that is, these are formulas for what we call permutations and combinations. Now, you'll notice the exclamation points. Those are not variables. Those are actually an operation, and that's going to be kind of cool. I'll show you that real quick. Let's say I had 4, and I wanted to perform this operation. Well, this basically means 4 times 3 times 2 times 1, which is equal to 24. So when you see something with an exclamation point, you'll multiply that number times the number before it times the number before that, all the way down to 1, which is kind of cool. And now down here, you can see a formula from statistics as well. This is what is called the sample variance. So this formula will represent something that is unknown but will become known. And these can be changing, but probably won't be because they're going to be numbers that we gather from data. And then down to the bottom right, we can see another graph, and that kind of shows your independent variables, which are weekdays, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then your dependent variable, which is the audience, it looks like. So just kind of some interesting things about this. And now what we're going to focus on for the next part of the algebra segment of the summer is variables as changing quantities. And specifically, that's going to be in the form of functions. And we'll get into what those mean next time. But for today, to summarize, variables are known or unknown, variables are changing quantities, and variables can be independent or dependent. And the point of this video was to kind of ease any sort of uncertainty about variables as you're getting into them in middle school and high school, and kind of get you comfortable with seeing them, because they're going to be common and you're going to be asked to solve for them and figure out what they are. And the main application of these that you'll see is variables as known or unknown quantities. And you'll want to change an unknown variable into something that is known, hence solving for it. But additionally, you will see variables as changing quantities, and we're going to go over that primarily in the next video. So until then, have a good rest of your day, have a good week, and we'll see you next time.